Good morning, everyone. In today's lecture, we are going to take a look at consumer demand theory. Precisely, we're looking at utility and consumer preferences. So here we begin the lecture by looking at the issue of utility and how we measure the satisfaction that is derived from a particular good. So the concept of utility is used in the analysis of consumer preferences. A consumer demands a good because of the satisfaction he or she expects to derive from it. So utility in this regard reflects the ability of a good to satisfy an individual consumer's wants. So one unit of measure of utility is referred to as util. So let's say, for example, an individual decides to buy good X, 1 unit of good X. So if the total utility associated with 1 unit of good X is, let's say, 5. So it means that the consumer derived 5 utils from the consumption of 1 unit of that particular good. So again, as the consumer consumes successive amount of the good, the total utility increases. But what happened? As the consumer consumes additional units of the good, the additional utility derived from the good as a result of consuming an extra unit will decline. So that is the concept of marginal utility. So we are going to look at those aspects of it. We're going to measure marginal utility as well as total utility. Then we'll try to derive the two curves. Now let's look at total utility. Now total utility here refers to the overall amount of satisfaction derived from the consumption of a good. So the marginal utility, therefore, is just the extra satisfaction that is obtained from the consumption of an additional unit of the good. So if we have a total utility function, the marginal utility from that total utility function is obtained by taking the slope or the derivative of the total utility function. So that is just a measure of the additional satisfaction derived from the consumption of an extra unit of the good. So that is the marginal utility. So the marginal utility there is just MUX equals to du dx, which is equals to the T du dx. Du dx, or delta U over delta X, is equals to du dx. So that is the marginal utility of good X. So if we are taking one particular example here, let's say the consumer only decides to consume one good. Let's say there is only one particular good in his basket. So if the total utility is given as U of X, then the marginal utility is just the change in utility, which is delta X, over the change in quantity, which is delta X. So the change in utility is delta U over the change in the quantity, which is delta X. So delta U over delta X is the marginal utility of that good. So it is just the additional satisfaction derived from the consumption of that good Now, let's look at total and marginal utility schedule here. So the quantity of the, so we have a table here where wherein we have the quantity of the good X, total utility of good X, and then marginal utility of good X. Now, if the consumer decides to buy 0 units of the good, then total utility, of course, is 0, marginal utility is 0. And if the consumer decides to buy 1 unit, let's say, for example, this is hamburger, right? So if he decides to buy 1 hamburger, then it's going to derive 8 utils of satisfaction from the consumption of that. But what happened here? The marginal utility is also 8 because delta U is 8 minus 0, and then delta X is 1 minus 0. So delta U over delta X is 8 minus 0 divided by 1 minus 0. The answer is 8. So that's why we have a marginal utility of 8 over there. Now, let's say, for example, now the consumer decides to increase his consumption of hamburger. So if he decides to eat another hamburger, so that makes it 2. So the utility derived from this will be 14 utils. But what happens to the marginal utility? It declines, right? So it declines. It declines because the extra unit, the extra satisfaction from the consumption of an additional unit declines. So that's why we see a fall in the marginal utility here. Again, it is just 14 minus 8, which is delta U, over 2 minus 1, which is delta X. Delta X is 1, and then 14 minus 8 is 6. So 6 over 1 is just 6. So that's how we got 6 over there. Now, if the consumer decides to consume another unit, let's say 3, so the total utility is given as 18, but the marginal utility declines to 4. So this process continues up to a point where marginal utility becomes negative. That is at maybe 6 units of the commodity, 6 hamburger. So if the consumer decides to eat 6 hamburger, the marginal utility there is going to be minus 4. And the total utility there is 24. So 24 minus 20, that gives us minus 4. Now notice that at point 4, at 4 units of the 4 units of hamburger consumed, we notice that the total utility is 20. And then at 5 units, the total utility is also 20. So that is referred to as a saturation point. That is the point where the consumer will not accept any additional hamburger. So you see that the total utility there is 20, but the marginal utility drops down to 0. It drops to 0. So if you give this individual any other amount of hamburger, so the marginal utility will continue to decline. It goes to minus 4. It will continue to decline. And so this actually reflects the law of diminishing marginal utility. Now let's look at a diagram here. We have the total and marginal utility schedule here. So if you look at the marginal utility, the green line, and the total utility, you notice that at 5 units of hamburger, the total utility assumes a maximum point. So it assumes a maximum point. And then at that maximum point, at the point where total utility is at a maximum, marginal utility is equal to 0. So as total utility increases, we notice that marginal utility continue to decline as the consumer consumes more units of hamburger. The satisfaction that it derives from the consumption of an additional unit declines as it gets more hamburger. In other words, the satisfaction becomes less and less as it consumes more units of hamburger. So that's why you see the inverse relationship here between the total utility and the marginal utility. So the marginal utility curve is just has an inverse relationship with the quantity. So remember, the quantity here, Qx, is on the horizontal axis, and then we have marginal utility of x here on the vertical axis, and then we have total utility x on the vertical axis. So as the individual consumes, continue to consume additional units of the good, the total utility increases. It increases up to a particular point and then declines thereafter. So the point where it declines reflects the concept of diminishing marginal utility. So this brings us to the law of diminishing marginal utility, which states that each additional unit of a good consumed essentially gives the consumer less and less extra satisfaction. So the negative slope there of the marginal utility curve denotes the law of diminishing marginal utility. Now let's look at the cardinal and ordinal utility here. So as I said earlier on, the cardinal utility refers to an actual measure of the satisfaction the consumer derives from the consumption of the good. And cardinal utility usually attach values to utility or satisfaction derived from the good. For example, 10 utils, 14 utils, 16 utils, 24 utils, etc. On the other hand, ordinal utility ranks the utility obtained from the consumption of a good or basket of goods. Ordinal utility specifies that consuming 2 units of a good gives the consumer more satisfaction than 1 unit. So the individual derives more satisfaction when he consumes 2 hamburgers than 1 hamburger. That's why you see the total utility there increases, is higher. So it derives more satisfaction. But what happens here is the marginal utility declines. So which is what? The extra satisfaction derived from the consumption of an additional unit. It declines as the consumer gets more and more of hamburger. So this particular concept of ordinal utility, which ranks the utility obtained from the consumption of a good, employs indifference scope analysis to analyze consumer choice or preferences. So we're going to look at those aspects, and that's where we're going to derive a lot of demand functions, the Hixian, the Marshallian demand functions, etc. But this utility concept was first introduced by three renowned economists in 1870. William Jevons, Carl Menger, and the French economist Leon Walras. So when we move to general equilibrium, or when we study general equilibrium, we are going to look at the Walrasian cantonment process. So we also look at the issue of excess and excess demand and excess supply. So in the general equilibrium setting. So there we're going to look at the Walras and cantonment process, and we also look at the Edgeworth box, and then we try to derive the contract curve. Now, let's look at consumer preferences here. So the consumer preference just shows how an individual consumer would rank any two bundles of goods, assuming that the bundles of the goods were available to the consumer at zero cost, at no cost. So the bundles here are referred to as the basket of the goods. That is the combination of various goods consumed by an individual. So one particular basket of goods can have so many types of goods. Can have clothing, shoes, food, maybe computers, cars, cell phones, etc. So one particular basket may have so many goods, different types of goods. Now let's look at a pictorial representation of consumer preferences. We notice that at point A, the consumer has 80 units of food in his basket and 0 units of clothing. That is to say, he consumes nothing of clothing. It doesn't consume any clothing. So there is no clothing in that particular basket. So it consumes 80 units. But let's also look at the case of B. At point B, it consumed the same amount of food, but 10 units of clothing. So that particular basket is more preferable to basket A because the consumer gets the same amount of clothing or consumes the same amount, the same amount of food, but at this time he has 10 units of clothing. So this means that point B is preferable to point A. So he prefers point B to point A. Now the same thing applies to point C. A consumer will prefer point C to point B and C because at point C, he consumes the same amount of food but more of clothing than the other two bundles, B and A. So at point C, the consumer is better off at point C than at point B and A. Now let's compare point C and point E. At point C, the consumer consumes more of both goods than at point A, than at point C. Sorry. At point C, the consumer consumes more of both goods than at point E. So because it consumes more of both goods at point C than at point E, we say at point C, the consumer is better off than at point E. So every rational consumer would like to be at point C rather than at point E. At the same token, a rational consumer would like to be at point E relative to point H. Because at point E, he gets more of both goods, and at point H, he gets less of both goods. More is preferred to less. So the consumer would prefer to be at point E than at point H. So when we move on to the issue of the concept of indifference curve analysis, we are going to look at how the consumer make his choice decisions. That is, it chooses the bundles, the basket of goods that are higher on the indifference curve than those ones that are lower on the indifference curve. So in other words, for the indifference curve, all the points along the indifference curve, all the points gives the consumer the same amount of satisfaction. But any indifference curve higher than the indifference curve where the consumer is at the moment gives the consumer greater amount of satisfaction. Now, if we look at point C here, now point C is on a higher indifference curve relative to point E. So that is why the consumer prefers to have to be at point C rather than point E, because it gets more of both goods than at point C than at point E. At point E, it gets less of both goods. So any rational consumer would like to be at point C rather than point E. Likewise, a consumer would like to be at point C rather than point F, because at point C, even though it gets the same amount of clothing, but is better off because it has more of food at point C than at point F. So it's better off at point C than at point F. So I'm going to stop so far today, and we're going to look at indifference curve analysis in the next lecture, and hopefully we'll try to do some mathematical analysis to derive the consumer demand function, and then we look at some other special aspects of indifference curves. Thank you.